This truck is carrying something longer than a football field, and somehow it has to drive through mountain roads designed for normal cars. Up ahead, the road bends into a tight hairpin corner carved into the side of the mountain. Even small cars struggle to make the turn. But the truck isn't carrying steel pipes or construction equipment. It's transporting a giant wind turbine blade. The blade stretches nearly 90 meters long. So long that from a distance it almost looks like the wing of a massive airplane moving across the landscape. And there's one obvious problem. The blade is far too long to make the turn. If the truck followed the road normally, the blade would swing right into the mountainside. So, the operators do something that looks almost impossible. Slowly, the giant blade begins to rise into the air. Hydraulic systems lift the entire structure upward, tilting it high above the road, almost like a giant spear pointing into the sky, allowing the truck to squeeze through the corner. Moments like this show you just how extraordinary the logistics behind modern wind energy really are. Because before a wind turbine can generate any electricity, its blades have to first arrive one of the most difficult transports on Earth. At first glance, these blades look almost weightless as they spin slowly through the air. But up close, their true scale is hard to comprehend. Modern wind turbines can reach lengths of 80 to more than 100 meters, longer than a football field, and roughly the same length as a passenger airplane wing. And yet, despite their massive size, these blades are surprisingly light. Most are built from fiberglass and carbon fiber composites, materials strong enough to survive decades of powerful winds while still being light enough to rotate efficiently. A typical blade can weigh anywhere from 15 to more than 35 tons, depending on the turbine design. That might sound heavy, but for heavy transport trucks, weight is not the biggest problem, length is. Unlike industrial machines or transformers, turbine blades are extremely long and slightly flexible. In strong winds, the tip of the blade can flex several meters. Now imagine trying to move a 90-meter object through normal roads filled with intersections, bridges, traffic lights, and tight corners. The blade can't simply bend around obstacles. It has to pass through them with only a few meters of clearance. And that is exactly why transporting these blades has become one of the most complex challenges in modern heavy-haul logistics. Moving a wind turbine across a country sounds simple at first. Just put it on a truck and drive it to the wind farm. But the moment you look at the road network, the real problem becomes obvious. Most roads were never designed for objects that are 90 meters long. Roundabouts are built for normal trucks. Village streets were designed for small cars, and mountain roads often include extremely tight switchbacks that force long vehicles to slow down or even reverse. For a turbine blade transport, every one of these obstacles becomes a serious challenge. A single roundabout might be too tight for the blade to pass. A bridge could be too narrow. Traffic lights, road signs, or overhead power lines may sit directly in the path of the blade. Even roadside trees can become a problem when the load stretches dozens of meters behind the truck. And the destination makes things even harder. Wind farms are rarely built next to highways. They are often located on remote hills, open farmland, or mountain ridges where the wind is strongest. That means the final kilometers of the journey usually happen on small rural roads, far from the wide highways used during the first part of the trip. By the time the truck reaches these roads, the real test of the transport operation is just the beginning. Because now, the convoy has to navigate turns that seem physically impossible for something this long. Moving something this long requires equipment that looks very different from a normal truck trailer. A standard flatbed simply can't handle a wind turbine blade that stretches close to 90 meters long. Instead, heavy haul companies use specialized blade transport systems designed specifically for this job. At the front of the transport is a powerful tractor unit, a heavy truck responsible for pulling the load. But the real engineering happens behind it. The thick base of the blade, known as the root, is clamped into a heavy steel mounting frame attached directly to the truck. This adapter locks the blade securely in place and allows the transport system to control its movement. The rest of the blade extends far behind the truck. Instead of sitting on a long trailer, the far end of the blade is supported by a separate rear trailer, often called a steerable dolly. This rear unit has multiple axles and can steer independently from the truck. As the truck enters a corner, the rear dolly can pivot and steer in different directions, allowing the long blade to snake its way through tight roads. But modern wind turbine blades have continued to grow longer every year. And eventually, even this system will no longer be enough. To solve this problem, engineers developed something called a blade lifter. This hydraulic system connects to the blade root and can slowly tip the entire blade upward during transport. Instead of staying horizontal, the blade can be raised high into the air, sometimes tilted up to 60 degrees. By lifting the blade, the transport effectively shortens the space it occupies on the road. This allows the truck to pass obstacles like steep slopes, narrow turns, or roadside barriers that would normally block a blade of this size. Without these specialized trailers and lifting systems, transporting modern wind turbine blades across normal roads would simply not be possible. The goal is simple. Make sure that the blade can physically pass through every turn along the way. Sometimes the simulations reveal problems. A roundabout might be too tight. Power lines might hang too low above the road. When that happens, small changes have to be made. Traffic signs may be temporarily removed. Trees along the roadside might be trimmed, and in some cases, utility companies even lift power lines while the transport passes underneath. Because if the blade can't clear a single obstacle along the route, the entire transport operation can come to a stop. And with cargo this large, turning around is simply not an option. Before the long journey can begin, the blade has to first be carefully loaded onto the transport system. This usually happens at a wind turbine manufacturing plant, a storage yard, or sometimes at a port where the blades arrive by ship. Once everything is aligned, the transport crew carefully checks the balance of the load and secures all connection points. Only when every system is verified does the convoy prepare to move. Because once the truck leaves the yard, there is very little room for mistakes. Once the blade is secured and the convoy is ready, the transport finally begins. The first stage of the journey usually takes place on highways. Compared to what comes later, this part is relatively straightforward. Wide lanes and gentle curves give the long transport enough room to move safely. Even so, the convoy never travels alone. Escort vehicles drive both in front of and behind the truck, warning other drivers and helping manage traffic around the oversized load. In some regions, police vehicles may also assist with traffic control at major intersections or on highway exits. The truck moves slowly and steadily, often far below normal highway speeds. Drivers have to constantly monitor the position of the blade behind them, making sure that it stays perfectly aligned with the road. But the highways are the easy part, because sooner or later, the convoy has to leave the main road. And that is where the real challenge of transporting a wind turbine blade really begins. The final route to many wind farms leads through narrow rural roads or steep mountain terrain. These roads were never designed for vehicles carrying cargo that stretch nearly 90 meters behind them. And this is where the transport really becomes extraordinary. As the truck climbs higher into the hills, the road begins to twist and turn. Tight bends appear more frequently, and the margin for error becomes smaller with every kilometer. Then comes the moment every transport crew prepares for: a hairpin turn. From above, the road almost folds back on itself. Even buses and long trucks must slow to a crawl to make this corner. For a wind turbine blade, the situation looks almost impossible. If the blade stayed horizontal, the rear end would end up swinging far beyond the edge of the road or crash directly into the mountainside. This is where the most impressive tools in heavy transport comes into play: the blade lifter system. Hydraulic cylinders connected to the blade's root system begin to move. Slowly and carefully, the massive blade starts rising into the air. Meter by meter, the tip of the blade lifts higher above the road. Soon, the blade is tilted steeply upwards, sometimes reaching angles close to 60 degrees. Instead of reaching far behind the truck, the blade now points high into the sky. By lifting the blade like this, the transport effectively reduces the amount of horizontal space it occupies. This dramatically shortens the turning radius of the entire load. Now the truck begins to maneuver. The driver creeps forward at a walking speed while the rear support trailer steers independently, following a carefully calculated path through the corner. Escort teams watch from multiple positions, guiding the driver by radio. For a moment, the giant blade towers above the road like a massive spear pointing toward the clouds. Then, slowly, the truck clears the turn. The rear trailer follows through the corner, the blade begins lowering again, and the convoy continues climbing the mountain. Watching a transport like this in person, it's hard to believe. A structure longer than a football field has just navigated a road designed for ordinary cars. And it raises an interesting question. Would you feel comfortable driving next to a truck carrying something this massive? Because for the transport crew, maneuvers like this may happen many times before the blade finally reaches its destination. Even with the advanced trailers and blade lifting systems, transporting a wind turbine blade is never routine. Every journey brings new challenges that the transport crew have to constantly manage. One of the biggest concerns is wind. A turbine blade may weigh tens of tons, but its enormous surface area can still catch strong gusts. Crosswinds can push against the blade like a giant sail, especially when it's lifted high in the air. That means that operators have to carefully monitor weather conditions throughout the entire transport. If winds become too strong, the convoy may be forced to stop and wait until conditions improve. Road conditions also play a major role. Many wind farms are located far from major infrastructure, which means trucks have to travel on narrow rural roads with soft shoulders and uneven surfaces. Drivers must position the truck with extreme precision to avoid getting stuck or damaging the road. Transport operators also require constant coordination between the driver, the escort vehicles, and the ground crews. Radio communication is essential. Teams positioned along the route help guide the truck through the tight spaces, watching clearances and warning the driver about any obstacles ahead. In many regions, these transports are scheduled at night when traffic is lighter and roads are easier to control. But even then, every movement has to be slow, careful, and deliberate. Because when you're moving something this long, there's very little room for error. After hours, and sometimes days of careful driving, the convoy finally approaches its destination, the wind farm. By this point, the truck has usually left public roads behind and is traveling on temporary construction roads built specifically for the project. These roads are often made from compacted gravel and designed wide enough for the massive transport vehicles. But even here, the driver has to drive slowly. The blade is still nearly 90 meters long, and the road may be winding through hills, construction areas, and unfinished turbine foundations. But eventually, the convoy reaches the staging area. This is where the blades, tower sections, and turbine components are temporarily stored before installation. Cranes will later lift the blade high into the air and attach it to the turbine hub, sometimes more than 100 meters above the ground. But the most dangerous part of the blade's journey is now over. After traveling hundreds of kilometers across highways, villages, and mountain roads, the blade has finally reached the place where it will begin generating renewable energy. Wind turbines have grown dramatically over the past 2 decades. As engineers build larger turbines, they can capture more wind and produce more electricity. And one of the easiest ways to increase a turbine's power is making the blades longer. Longer blades sweep a larger area of air, which allows the turbine to generate significantly more energy. But there is that hidden limitation: road infrastructure. At some point, the blades can become so long that transporting them through normal roads becomes extremely difficult or even impossible. Tight roundabouts, narrow bridges, mountain roads all create physical limits on how large turbine blades can be. In fact, transport challenges have already started influencing turbine design. Engineers not only have to think about how a blade performs in the wind, but also whether it can physically travel hundreds of kilometers by truck. This means that the future of wind energy is connected not to just turbine technology, but also to the trucks and transport systems capable of moving these enormous blades. The next time you see a wind turbine slowly turning on the horizon, it's easy to forget how that massive structure even got there. Before the tower was raised and before the blades ever touched the wind, each one had to complete an extraordinary journey across highways, through villages, and even up narrow mountain roads. Transporting something longer than a football field through normal infrastructure requires specialized trucks, careful planning, and incredibly skilled drivers. And it raises an interesting question. Do you think you could handle a truck carrying a blade this big through mountain hairpin turns? Let me know in the comments. If you found this video interesting and informative, please make sure to like and subscribe for more videos about extreme trucking, heavy transport, and incredible logistics operations. Thanks for watching, and I'll see you in the next video.